So let's kind of talk about the changes that are going to be done for this semester compared to your last semester. Um, the syllabus is going to be changing slightly, or I should say, not the syllabus. The format of your semester is going to be changing slightly from last semester. We're going to try to make it a little more amenable to us, since being well, first off, you guys are in 1B. There's certain things that you guys are going to get a little slack on, but there are other things that are going to be tightening up, like the timelines and the schedules are going to be tightening up a little bit this semester. Let me pull up your syllabus, and then we'll go over one of the major changes. You guys already know the drill. Okay, so I've added another section where you guys are going to be graded on, which is called career preparation. I've kind of become a little bit aware that although counseling services is doing some things in terms of trying to get you guys ready to go transfer into your next level, I think there's a gap. And so I'm going to kind of use this segment to kind of push you guys to start thinking about your futures, and then also thinking about the careers that you guys are looking to get into a little more in detail. Okay, and so what is that going to mean for you guys right now? So one of the things is that you're going to have to get a plan. You're going to have to get a schedule that you're planning to do for the next couple of semesters. And that's going to need to be submitted to me. That's going to count towards your grade. It's only 4% of your grade. So, I mean, I want you guys to do a good job on it because it's your future. But I also want to make sure that you guys are, it shouldn't take you 3 months to sit there and get it done. You know what I'm saying?
Yeah.
Okay, so that's one thing. The other thing is that I want you to look at the possibilities. So you guys are all going for certain degrees. I know Selena is planning to be a bioengineer. Selena actually had contacted me. You don't mind if I call you out a little bit, Selena, do you?
No, I don't mind at all.
Okay, so Selena actually contacted me and asked me, would it be better for me to become a mechanical engineer, or would it be better for me to become a bioengineer? Well, a mechanical engineer and a bioengineer are two totally different things. They have two totally different job markets that'll be available to them, in addition to all of the other ones that you can fall back into, right? So, for instance, a bioengineer is actually you're biologically making alterations to genetic code, or making alterations to proteins for vaccine development, or for organism development, or for, let's say, you guys know about oil spills, and that there's certain bacteria that are actually used to clean up oil spills. Did you guys know that?
Yeah.
A lot of those bacteria have been bioengineered so that they would only target that particular type of oil. So then they're cleaning out that oil under those circumstances. So you don't want it to sit there and wipe out all of the oils in the world or anything like that. So you want to sit there and make sure that it's typically targeted. And so they've modified those bacteria. And so that modification is typically done by a bioengineer. Where a mechanical engineer, you can do car design, you can do, let's see, pulley systems that are used to sit there and move beams. You can do, there's a lot of things that you can do with mechanical engineers. It's a very broad base. There's also a lot of things that you can do with bioengineer. And so the thing is that there are two different markets, and they target two different areas. So you're not competing for the same jobs unless you decide you want to teach. And then if you just have engineer at the end of your name, then a lot of schools are like, oh, he's an engineer, so we're going to hire him, So then you're competing for the same market in that situation. So you can go to specific markets, or you can go to something that's very general. And so I want you guys to start investigating that. And part of that is to try to reach out to somebody who does that you're interested in, and see if they would spend time to at least talk to you or talk to the class. Okay, so there is going to be exactly 20 of you guys all together. So what I'd like you guys to do is, we're going to have part of a mini group project, is those who have similar majors. Like if you're independent, hey, it's cool, you're independent. But if you have majors that are very similar to somebody else's, we're going to have you guys work as a group, and then you guys together try to contact someone to come in and talk to the class and talk to you about their job. How do you feel about that?
Yeah, that'd be cool.
Okay, good. So, unfortunately, last semester we didn't get as far as I would have liked us to get. So if I recall correctly, you guys all have chapter 6. Is that, am I right or am I wrong?
Yeah.
Yeah, so that should have been part of the handout series that I gave you. So we're going to be heading back. I believe it's chapter 6. Maybe I'm looking at the wrong one. Hold on. You got to remember, I have so many classes, got to keep them straight sometimes. Yeah. So we're going to be going over chapter 6 notes. We'll start them today here in a few minutes. So if you got to have those notes, you want to be pulling those out. But chapter 6 actually deals with quantum mechanics, quantum chemistry. We'll kind of talk about it and kind of give you guys a quick run through of things. And we want you guys to try to understand the spectrum and things to that extent as well today. So we will be starting at chapter 6. And then we'll do chapter 7 and chapter 8. And then we did chapter 9, which was gases, but we're going to briefly touch on the last components of it that I think are kind of important, particularly because of the advancements that have been made currently. And so there'll be a small segment of chapter 9 that we'll be doing, and then chapter 10 and onward. Chapter 10 is pretty cool. That's when we start really getting into starting applying some of the things that you've already learned. Okay. Okay, let's see. Okay, so what else do I need to talk to you about? On here, I've also listed all the important days. I know that none of you guys are planning to drop any of the classes. Oops. So I know none of you guys are planning to drop a class, so I'm not so worried about that. And if you are thinking, if you're feeling overwhelmed, come and talk to me, please, because then I'll talk you off the ledge. I'll keep you from jumping off the bridge, you know, okay? I know that life happens and things are gonna happen, right? You know, you may, your mom may get COVID, or your dad may get COVID or something like that. Again, let me know what's going on, so then that way I can, you know, kind of, again, talk you off those bridges. So we don't want you to sit there and drop the class, because you guys have come so far and we don't want you to have to start all over again. You know, although you wouldn't have to start all over again, but you made it to 1B. Come on, let's go ahead and finish it. The other thing is that in the fall, right now on the books, it's slated to have organic chemistry. When they offer that class, I don't know how many of you guys are going to need organic chemistry. I know Selena will.
I
You're
think
getting away. Yeah, you're not getting away. And Taylor, if I remember correctly, I think you're going to need it as well. And I think Kathy is also.
Yep.
some of them are saying that as long as you have a full year of chemistry, they're taking that as your OChem requirement.
Are you serious?
Yeah.
That's interesting. I've never heard that. Because
Yeah.
even though that we're going to touch on organic chemistry, it's not going to be to the level that you're going to need.
Okay. Why are you breaking my heart so early in the morning, Dr. Henry?
Sorry. It's just because I love you. I don't want you to make those mistakes, you know. And it's funny because, you know, this is the thing that a lot of times it really depends on the school that you go to, right? What
Yeah.
they'll say. And then also what happens a lot of times is that you get there and you may be the incoming class. And then as soon as you get there, they make that quick change. And then you're going to have to take it there.
Mm-hmm.
Yeah. So also kind of be prepared for that. So that's going to be kind of important for you guys to kind of pick the schools that you want to go to, because their requirements may be slightly different than others.
Matt, have you heard anything about that? Because I know you're a PA too.
I mean, yeah, it really just depends on which school.
Yeah.
The school I'm trying to get into doesn't require organic, but then there's another one that I'm looking at that does. So
Yeah.
just
And you
depends on.
also, because you guys are going for postdoctoral degrees, so like professional degrees
Yeah.
as well. So you also want to take a look at what the requirements are for your professional degree as well, because you know, you may go ahead and finish your program, your BA, but you guys are looking to be physician assistant. That's another level. And so what may be required for them may be a little bit more. So you want to start looking at I mean, you want to really be looking at the future. You want to be looking at that next level, the BA or BS level. Then you want to be looking at your professional degrees, your master's, your PhD, your doctorate, so
Yeah.
those, you want to be looking at that next level as well too, and what's going to be required to get into those programs. And so you want to get in that mindset of always looking at least 2 levels ahead.
Okay.
If you're not looking 2 levels ahead, you're behind. You guys get that?
Yeah.
You got that, Selena? Good. Okay. So you guys are gonna have a lab pickup. It will be the second. It'll be, sorry, not the second. It'll be this Friday, Saturday, and Monday. I will actually be posting the times, and I'll email you the specific times. I'm ironing them out, and I'll email you the locations, because we're going to have a location at NDC, in Coalinga, and in Lemoore. Okay. I just haven't figured out where I'm going to have it at in Lemoore, and who's going to be there. That's my last part that I'm trying to figure out. Okay. So, and I know Cassie, I know you're back in the boonies, and so in Tulare County. So,
Yeah.
we always can make an arrangement for, because I like
Well-
to go out there and get my special meal every paycheck. So I'm gonna get my special meal, so we can kind of make arrangements that I can take a trip up there at some point.
If not, I can head out to Lemoore. I'm going to be on campus today too. So.
Okay, good. I don't need to talk to you guys about academic honesty, because you guys already know. This is the benefit of having people that come from one class to the other class. You guys are kind of like the cream of the crop. So you guys are the ones that made it through. Not everybody made it through. You'll see some of your colleagues dropped off. Some of them dropped off because they're engineers and they think they don't need the second half. And so until they start trying to go to schools other than Fresno, and also Fresno is also getting ready to change their requirement for their degree as well too. So to include another level of chemistry. So I don't need to talk about those things. You can look over them. If you have any questions, again, talk to me. And your group project. So your group project is going to be modified. So you guys submitted a paper last semester, right? And so what you guys are going to do, I'm going to send you guys a copy of your paper, the papers that were submitted, and I want you guys to read that. So then you guys are going to write a review on that paper, and then you're going to choose one of these methods that you feel that is the best. You're going to rank them from 1 to 10, 10 being the best, 1 being the worst. Okay. And so, and based upon the ranking, the top 2 are going to be the 2 projects that we're going to pursue. You guys are technically supposed to meet 2 times the semester face to face. Okay. And they're going to be long days like they were the last time. You guys had, depending on the section you chose a certain day. So we're going to try to accommodate the way that you had chose, because you picked those days for apparently a good reason, and you probably marked them on the calendar. We've also, normally I would have a section at NDC and a section at Coalinga. This time they decided to combine both of them, so they canceled the other section for NDC. So NDC is part of this as well. So we're going to have to try to make accommodation for them to do exactly the same thing that you guys are doing. And so your group members are not going to be the same as the group members that you had the last semester. That's the point. We're going to have a Coalinga team and we're going to have an NDC team. And Cassie, again, you're probably a little screwed on this, and so, but you guys will figure things out. You're going to be on campus, so we're going to try to sit there and time it so you guys are there all together. In addition to that, every 2 weeks on Saturdays, me and the TAs are coming in to kind of clean up the lab and try to get it organized and format it. And what we're going to do is have what we call an open lab for you guys on those, not Saturdays, on Sundays. Have an open lab period, and it'll be typically from like 1 to 4 p.m. So it'll be like a 4-hour block, 3-hour block. So you guys can come in and kind of work on your projects as you go. I am going to be getting bucket seats. There's going to be one located in Coalinga. There's going to be one that's going to be located in NDC. And so that you guys can test out your chemical concoctions on and see how effectively they work. Okay. So I'll be hopefully picking those up, not this weekend, but next weekend. So February February 14th, which is my birthday, we'll be actually having one of those open sections. Okay. Okay, are we good so far?
Yeah.
Yeah.
Okay. So are there any questions? Okay, you got your pens ready?
Yeah.
Okay, good. So on February 25th at noon, there's going to be a Black History. All right, let me start off with February the 18th. There is going to be part of the Black History Month tradition. There's going to be an open mic event happening. So February 18th, and that's going to be at 5:30 p.m. and it's going to be virtual. So it's not going to be face to face. You just have to click on and log on and watch and vote. You know, so that's going to be happening. So the way this is going to work is we're going to have what we call open mic, or they like to call it like a talent show. So you come in, you do a performance, you sing, you dance, do a combination of both, you upload a video. So those videos are going to be due February 10th. I'll be putting up a link that's specific for that under that topic. You'll see it pop up under a Black History event. What I'm doing to kind of promote it a little bit, if you submit a video for the performance, you'll get 10 extra credit points added on to your test scores. If you attend the performance, you get 3 extra credit points added on to your test score. You guys get that?
Yeah. So it's like last semester, or it's like last spring.
Yeah.
Okay.
Yeah. And then on February 25th at noon, for Black History Month, again, we're going to have a keynote speaker and a panel. That's, again, happening at noon. It's going to be a virtual event. And if you attend that, you're going to get 5 extra credit points.
You said the 18th was at 5:30 or 5?
5:30. Yeah, we're trying to give people at least a little bit of time to get home, you know. And again, February 10th is when the submission must be completed. I'll give you the link where you can submit. So I know all of you guys are going to be submitting. I want to see those TikTok dances, and you know.
It has to be a performance. We can't do a reading like last time, Dr. Henry.
You can do, yeah, you can do a reading. You can do a, you know,
Okay.
you can do what you want to do, right? And if you want to do a poetry slam, you can do poetry slam. That's fine, you know. You do what you do, you know. If you want to do mime, you know, do a mime, you know. The key is that we want to sit there and try to get students engaged in a sense, right? So our last year's winner was Raul. Raul was one of my former chemistry students, and he was on my, I had talked to him, and he's like, yeah, I played the guitar. He had told me that a long time ago. I'm like, I hear you. I said, I remember you telling me you played the guitar. So I went up to him, you played the guitar. Why don't you do, you know, do a song and everything like that? And he's like, Dr. Henry, I do rock. And I'm like, so what? I said, go up there and do a rock song. You know, I said, do you? And he actually won the event. And so, by the way, I forgot to tell you this. There are prizes. So there's a first place prize, there's a second place prize, and there's a third place prize.
Yeah.
So, again, we want to try to get you guys engaged and get you involved in the community and positively interacting with communities. So. Okay, questions, concerns, Cash?
I'm still poor, Dr. Henry. Stop asking for cash.
That's right. So how do you think I fund all of these other, you know, behind the scenes activities? I use that cash, you know. Let's see. Okay, I think I've covered everything. So we talked about career preparations, we talked about your group project, and we talked about Black History Month. And again, all of that, I'll be putting up the flyer and everything on the Canvas shell, so you guys, it's going to be a click and take you there type of situation. I just need a little guidance because I haven't quite figured out how to put this particular flyer into the thing because it's a different format. I'm a little slow at getting all your lectures uploaded, and I'll work on that. I'll try to get them all in there for the semester, and some of them are going to be modified because, like I said, we're making some changes that'll accommodate you guys a little bit better and accommodate me better. And plus, all of the lectures from a certain point I had borrowed from Mr. Abella, and Mr. Abella's style is quite different than my style in terms of how I make my lecture notes and how he makes his lecture notes.
Very much so.
So yeah, so I like my style much better. So there'll be, you're going to see modifications happening. Okay, it was slow at this. Are there any questions? Matt, any questions?
No, sir.
Kayla?
Nope.
Good. Okay, so this makes it easy. Okay, so let's go ahead and get started with today's lecture.
Well, this is gonna be fun. We're gonna get super singled out now because there's not enough people.
Yeah, I wonder how many people are going to make it to the evening class, you know, so at first there wasn't going to be a morning class at all. There was just going to be an evening class. But a couple of you guys have reached out to me, and so I'm working with you. Oh, that's the other thing I forgot to add. So there's no official lab for the morning section. So what you guys are going to be able to do is I have office hours. Most of my have office hours early. You can do your office hours then, or you can do your office hours, your lab then during those office hours. We can have it set aside for you, or you can do it in the evening lab like we would normally do. Okay, so those are your two options. The office hours is 1 p.m. to, I believe, 4 p.m. on Thursday. And then, so you'll be able to drop in there and do it then if you need to. And if worst comes to worst and you can't make it that day, then we can set up another time for you guys to do it. You can actually come in during the time that I have the 2A labs. And so we'll just kind of put you in a separate room. So, I'll go back and forth with you, but you have to let me get 2A started before you get started. Okay.
And then the other lab is on Mondays, right? Monday evenings.
Yeah, Monday evenings at
Okay.
7 to 10.
Okay.
Yeah, so my Mondays are going to be long days.
Mine too.
Yeah, I know, Cassie. I was like, damn, what are you doing?
Yeah.
But hey, we do what we need to do to get to where we want to be, right?
Yep.
Okay, so let me get to where I need to be.
Dr. Henry, do we still have to purchase Chem 101 as well for the semester?
Yes, but you should get a discounted rate since you were there last time. So yes, you'll still have to purchase it again, unfortunately.
Okay.
Yeah, I was trying to figure out a way that we can do it where you can just have one purchase. But the problem is that I didn't want to. So there were those students that were just only going to do the one semester, and then there are the ones that I know that were going to do the 2 semesters. And they offer both of those options, but it's weird on how they do it. So but they're supposed to give you a little bit of lower rate for the second one. Sorry, I was trying to figure out a way to make it work, but can't win them all. They're looking at it. They need to make money. The price has also gone up, so it's $33.95 now. But I think you guys are going to get a discounted rate since you're going to be consecutively using it. If not, you should also ask them. So
Does
now
that still count if like since I took the intro class with you?
Yeah, you should actually,
It
you should
was-
really get a super discounted rate. But no, it should still count for you and your
Okay.
under your circumstances as well.
Okay.
So, let's see. And they're also getting an organic chemistry modules, which I'm trying to test out to see what it's like. I have another company that had approached me this semester, and theirs look pretty good. I just have to look at the rigor and to make sure that it's going to work for me. So we may change, and their price is you get a book and the homework assignments all together in a single package, and it's all kind of automated and kind of like Chem 101 in its own right, but a little bit different. So I'm testing it out. I may actually ask a couple of you guys to take a look at it and tell me your opinion as well before I make that change. Sorry, I'm running a little ragged here. These are my come on. It's not popping up. I was up a little late last night, waited till the last minute to get a couple of things done, you know, so feeling like a student all over again. Okay. That's for me. This is for you. Question in the chat box. Cassie, you're going to be good. We're going to probably be finishing a little early today, since I didn't have to go over the. If I can get things started. Since I didn't have to go over the full syllabus and introduce you guys to each other. You guys all know each other, right? Come on.
Everybody except Selena.
You don't know Selena?
I don't think she was in our morning class, like on Mondays last
Oh,
semester.
no. She was in the evening class, I believe. Yeah.
Yeah.
Nice to meet you.
Nice to meet you too, Cassie.
You mean Kayla? That was Kayla talking to you, Selena.
I was just gonna correct her, but
That was weird.
Oh, it's okay. I know what you meant.
I'm sorry. Well, hi, Kayla.
Hi.
Okay, so we're going to be talking about electromagnetic energy. We're going to be kind of going over the Bohr model and kind of how quantum theory kind of developed slightly. And we're going to be talking about a shitload of equations that you're going to be responsible for. So start making sure that you kind of pay attention to those equations and kind of understand how they're working for us. Okay. And then, of course, we're going to be talking about electron configuration. Our formal name is electronic structure of atoms. And we're going to be talking about the quantum numbers specifically. And so there are going to be 4 quantum numbers that you're going to be responsible for. You need to be able to understand how those quantum numbers pertain to that particular electron in that particular atom. And then we're going to be talking about periodic variations in the elements. And so that's just kind of like how those electrons affect size of an atom and how they affect how an atom is going to interact with other things, electron affinity and things like that. So we'll be talking about all of those things in this chapter. And it's really important, particularly for those that are thinking about possible engineering aspects of things. That's bioengineering as well as just regular engineering, because how particularly proteins interact also have a lot to do with the electrons and whether or not they have charges or don't have charges. So that's going to play a huge role in the dynamics of certain proteins and how they fold and how they interact. Okay, so this is basically the Crab Nebula. Okay, it is composed of so much electromagnetic energy. And if you kind of take a look at it, you can kind of see all of the different colors. And so you see that red and those greens and all those. So basically, those are components of chemicals that are forming those colors. So for instance, the green is basically ionic charges of sulfur. The red are ionic charges of oxygen. And because they have these ionic charges, these rare ionic charges, they cause this color because it's an unstable form of them. And so they're going from one energy level to another energy level. And so those electrons, those lack of electrons or the addition of electrons can also cause excitation to cause light to be emitted. And so that's kind of the point of kind of showing this image here. So let's talk about electromagnetic energy. So electromagnetic energy kind of explains why we have light. So light is basically consistent of electromagnetic energy. So if we think about white light consists of all of the colors in the rainbow. So you guys, all you guys have taken 1A, right?
Yep.
And you guys remember doing the spectrum experiment where you guys came in and you had the, right? Everybody came in class. We looked at the little lamps, and then we also looked at the light and stuff like that with the little slide, right? So in that context, right? So if you guys actually put that little slide up there, and I think you guys have a slide in your kit too, right? Yeah. So you'll be playing with that here in a second. I'll have to send you guys some things to play with it. Or actually, it'll be in your kit. The rest of it will be in the kit. And I just wanted to be sure that I already had it in your kit. Everybody has that slide or have those glasses, one or the other.
Yeah.
Good. Do you guys still have your kits? Kayla, do you have your kit? I think you dropped yours off.
No, I dropped it off.
I turned mine back in.
Okay. So we'll have you guys, don't worry about it. You're good. Don't worry. You will have those kits available for you guys to pick up again. And then you guys really, you're just going to get an exchange of the chemical components that you're going to be adding. And there are going to be a couple of other electronic components that will be added onto that. Okay, so there's not going to be too much change to the kit that you have. You're going to have 2 electrical components added onto it that you're going to be using. And then they're going to be papers. And then I'm going to try to get a copy of all of the lectures that you guys are going to be doing from here to the end. It won't be in the first part. It'll actually, you'll get part of it the first part, and you get the other half the second part. Okay. Work in progress, you know. And they're going to kill me for killing so many damn trees too. So how many of you guys still have your periodic table and all that stuff, or do you guys need a refresher on that?
I have everything.
You have everything?
Yeah.
Okay. So then I don't need to make too many copies of that.
No.
Okay.
In my big old chemistry binder.
Yeah. And it only gets bigger, doesn't it?
I'm running out of room. I think I'm gonna have to upgrade to a second binder.
Yeah. So light has basically been studied for a lifetime. So Isaac Newton was one of the first guys to start, well, one of the many that has started looking at light. And so he basically, like I said, he kind of recognized that white light was composed of all these other colors, right? And so he was sitting there saying, hey, you know, light is probably these little tiny particles and everything like that that are traveling really, really fast, right? So he basically came up with the Newton's law of motion and stuff, kind of based upon what light was. In the 19th century, Thomas Young, he basically says that light passing through like a narrow object or like a slit kind of makes patterns of interference. So he was actually really, so the thing that Newton was saying, he was actually able to show, because if you basically put it through a narrow slit and a diffraction, you're able to sit there and separate the individual colors of that white light, okay? But he was like, you know, this doesn't kind of make sense with that concept of it being, you know, these Newtonian particles, you know, there's some things that don't quite make sense. And so he says, you know, maybe these are waves, because it doesn't quite make sense that it's particles that are doing this, because you have this interference pattern that occurred and you didn't have these like specific points. Okay. So then Maxwell comes along. Oops, get carried away. And so he says, well, maybe waves are a better explanation of, you know, what's going on in the situation. So then Maxwell comes along and said, hey, you know what? Let me do one better. It is waves, but it's electromagnetic waves. And so, and one of the ways that he actually showed this was by adding a magnet to light, and saw that there was a point of reflection of those patterns that he was actually observing. And so he says, you know what? It's something more than that. There has to be a little bit more than just it being a pure wave. Maybe it's a combination of a wave particle. So that's where we got this wave particle duality. And that's been what science has kind of been focusing on from here on out. So we went from that point where we just thought it was particles to the point where we just thought it was a wave. And then we kind of came to the point that it's a combination of both. It's wave and particles. And we're going to explain how that pertains at the chemical level. Okay. So you guys know what waves are. You guys been to the ocean, right?
Yep.
If I remember correctly, Matt is a surfer boy. Is that correct, Matt?
Right?
Yeah. So tell me about a wave. So how are you able to ride a wave? What is this its unique feature that causes it to be, you know, so fun to get on a surfboard and ride?
I don't know how you want me to answer that. It's
Answer the way
always
you want to answer
moving.
it.
There's always another one coming.
There's always another one coming. So you're saying that there's periodical movement of the wave, of the water, right? So if you look at the water, right, isn't it doing this? You know, where you're getting that, let me draw on your screen. Forget you guys can't see me all the time. Draw. Okay, hold on. Okay, so you guys are seeing the wrong screen. Let me share, new share. Should be this one. Nobody told me, you guys didn't tell me that you guys are looking at the little screen.
No. I
It's
didn't
morning. I
catch it.
thought your coffee hadn't kicked in, so
No, it hasn't, if you can tell, right?
I
So
was
look at
rolling with it like the wave.
Yeah. So we see that in the case of waves, water waves, you have that oscillating motion, right? And you have an oscillation motion over a periodic movement. Okay. So that's one of the aspects of waves. Right? And we see that in the water. It's beautiful. You know, see it crashing. You know, it's so beautiful. And then you see the surfers coming down. So they started at peak and then gradually the periods change on those waves, right? As they get closer and closer to shore. Right? But the point is that you have that oscillation occurring and you have that periodic movement. Okay. So that's what kind of a wave is composed of. Okay. And it has that energy. In that case, a lot of kinetic energy associated with it or transported it. Okay. So you guys think about, if you guys, have you guys shook ropes? Have you guys, any of you guys double dutch, you know?
Yeah.
Right? And then like you got the rope and then you whipped it up and down and it did all of that. And so you kind of see the rope shaking and it oscillating in that period for a while, right? Or if you throw a pebble on a pond, you know, splashes as it goes through and you can see the waves moving from where the pedal hit, right? Okay. So in all of these cases, kinetic energy, you guys are familiar with kinetic energy, right? Kinetic energy is transferring through the matter. It's transferring through the water, it's transferring through the rope, it's transferring through the air, okay? So we go back to that aspect of kinetic energy, okay? So that's gonna bring us to this equation. Put it on the screen, maybe. Where c represents the speed of light here. So in the case of light energy, v represents velocity. In the case of that pebble, okay? And m represents mass, because we know it's a particle. Particles have mass associated with it, okay? And E represents energy.
So that's just the kinetic energy equation combined with this other one.
Yes. Yeah. So the kinetic energy equation, Ke, which is energy, you know, is equal to 1/2 the mass times the velocity. Or in the case of light, instead of Ke, we just say E is equal to E equals mc squared.
So
Okay.
it's one or the other, depending upon what you're dealing with, right? If
Exactly.
you're trying to deal with light, then you do the mc squared.
That's right. And if
Okay.
if you're looking at kinetic energy, you're going to use 1/2 the mass times the
Okay.
velocity. Okay. Questions, concerns, Cash? And in the past, what I've done, and I'm not going to promise you this, but because you're going to get a lot of equations, like I said, particularly in this semester, you're going to get a lot of equations. So I'm going to start giving you guys an equation sheet, because me, I'm not big on memorizing. If you can't tell, I'm not until we get to OChem, then I'm going to have to make you memorize. That's the only way you're going to pass it. But a lot of instructors disagree with me on this, but it's conceptually, I want you to understand the concept. I don't want you to get bogged down and try to memorize an equation. Okay, so let me clear. So the speed of light waves are basically not going to be only restricted to the travel through matter, right? So you can do it through a vacuum, and then that's how we kind of measure the speed of light. Measure the speed of light through a vacuum. We know that the speed of light is going to be equal to 2.998 times 10 to the 8th meters per second. Okay. And the speed of light is exactly what I just told you. It is the speed, how fast light is traveling, right? Under perfect circumstances, that being the vacuum, it's always going to be 3.00, well, or 2.998 times 10 to the 8th. 3.00 times 10 to the 8th if we do 3 sig figs. Okay? Meters per second. Okay? So electromagnetic waves are going to be consistent of an electrical field that's going to be oscillating, and it's going to be perpendicular to a magnetic field. So if we think about it in terms of vector, so we have 2 vectors, right? So this here is going to be representing our magnetic field. How many of you guys have taken calculus?
Dropped
Anyone?
it.
I dropped mine.
Yeah.
My
You dropped yours?
pre-calculus. It was a
Okay.
lot. And I had chemistry. That was my first chemistry class too. It was just too much.
Yeah.
So
I didn't
Yeah, we
need it
can-
anymore, so I was like, see ya.
Okay, so we have this here represents the magnetic field, and then this here represents the electrical field. So the electrical field is going to be oscillating, but they're going to be perpendicular to each other. Now, together, they represent the electromagnetic wave. So together, they make that wave, but they're working perpendicular to each other to kind of account for that travel. So in that sense, you get something that's kind of in between the both of them. So do you understand what I'm saying there?
yeah.
Yeah. So we're going to talk a little bit about vector calculus, although you guys won't have to get into those details. But it's just going to be a little tad bit, because we're not going to need it, because we're going to kind of derive the equation that we're going to be using. Okay. But we're just going to touch on it. Okay. So just to kind of prepare you. So don't go jumping off bridges yet. Okay. But when you see it, it'll make sense to you. You'll be like, oh, okay, that's what he was talking about. Okay. Oops. Okay. So these are all things that are going to be used to characterize wave, their properties. we have what we call the wavelength. Wavelength is the distance between peak to peak or trough to trough. I'll show you an image here in a second, so you can kind of get an idea, a visual of it. Okay, and then frequency. Frequency is the number of cycles that occur between a time unit. Okay, so how many complete wavelengths passes between a time unit. And then amplitude is how tall it is, how big is those peaks, or how low is or how small is that trough, from peak to trough. That will be your amplitude, okay? Or half the distance between peak or trough. Okay, so now what do I mean by that? Okay, so here's my wave. This here represents wavelength, or we'll call it lambda. So it's the distance from peak to peak, or it would be the same difference from trough to trough. Although my wave is a little funky, but you know, technically if they were evenly distributed the way it was supposed to be. So, okay, so that's lambda, or the wavelength. Frequency would be the number of, let's say, we had a barrier here, right? So the number of waves that would be crashing in that barrier, right, at a given time. So in this case, we have 4, but we could have another wave okay, that will be going to that same period with a smaller wavelength okay, a smaller wavelength than this wave, right? So in that case, it's going to have a higher frequency than this guy, okay? So wavelength and frequency are often inversely proportional to each other. As the wavelength gets bigger, the smaller the frequency. As the frequency gets bigger, the smaller the wavelength. You guys see that?
Yeah.
Okay.
Is
So-
it safe to assume that all waves are uniform? All waves? Or do they change? Like
Okay,
your
so-
wavelength?
In a vacuum, the waves would be uniform. But
Okay.
if they're going through matter, what happens, you get what we call is a decay. So the wave actually decays. So in that case, they wouldn't be uniform in that situation.
So ideal circumstances, they are uniform.
That's right. And
Okay.
so often you'll have what we call like a diffraction index, and you would kind of use that to sit there and determine if you're putting your light through something, it's going to affect. And it kind of calculates that decay that occurs over time.
Okay.
Okay. So, what was I going to say? Wavelength. Okay, so this gives us C equals lambda. And this is not a V, this is really a nu. So it really should be looking like this, even though it looks like a V. It's a nu. Kind of hook on it. So like I have new shoes, but it's spelled NU, new. Okay, so, and I'm going to give you guys a sheet with the Greek letters because you're going to see those over and over and over again. So lambda times nu equals the speed of light. Okay, and it makes sense, okay, because the speed of light is a constant. It's always going to be the same. So if my lambda gets big, then that means my nu has to get lower to balance it out. So it'll always be the same thing. And if my nu gets big, then my lambda has to be smaller to kind of balance it out. Okay. Okay. So this here represents the frequency. This is going to be my nu. Okay. And amplitude you'll often see as A, just A, is just this here. So, or you can take the full thing and just one half that distance from the top to the bottom. So, which is just that top. Do you guys see that?
Mm-hmm.
Okay. Okay, so let's talk about frequency. Frequency is measured in, come on, in hertz. That's right. Or 1/seconds. So it's really cycles, the number of cycles per second. Okay, so that would be our frequency. So 1/seconds is equal to 1 hertz. 1/s equals 1 hertz. That looks crazy. Let me fix that. So it looks like a 1. Okay. So we often will hear megahertz or gigahertz, right? And so 1 megahertz is going to be 1 times 10 to the 6 hertz. 1 gigahertz is going to be 1 times 10 to the 9th hertz. Okay. Questions? Concerns? Cash?
Nope.
How was that on time? For some reason, I don't see my clock. Okay, there you go. Okay, so we've already talked about this. The speed of light is equal to the wavelength times the frequency. So whenever you're talking about light, right, you're going to be using this, right? Simple?
Yeah.
Okay, so let me ask you a hard question. So if I'm talking about blue light, am I going to use this?
Isn't it all light?
That's right. It's all light. Exactly. So it doesn't matter whether it's blue, orange, pink, or green. Any type of light, you're going to be using this. If they say electromagnetic energy or electromagnetic radiation, which is just light, what are you going to be using?
This.
Yep. Let's see. So, by the way, you guys have 2 tutors for this class. You'll have a new tutor added on, Cameron. I'll introduce you to her probably on Wednesday if I can get her to come in. And then she just has a really weird work schedule. And then we have Jessica. Jessica's back on board. So
She's back up?
yeah, she's back up. I thought we were gonna lose her. I have to fix her link and everything. But
Okay.
yes. So she's back with us again. Okay. So we've already talked about the fact that lambda and nu are inversely proportional to each other, right? And again, it really starts to kind of click here in a second, when you start looking at it in a little more detail. So this is just an example, same example I showed you just a second ago, right? So here we have 3 different wavelengths where here, the wavelength is greater, so then we have a lower frequency. Here, the wavelength is smaller than the wavelength 1, we have a higher frequency. And then here, we have an even smaller wavelength, and we have even greater frequency. Simple. Okay, and then here we have the amplitudes. So they're just showing you the difference in amplitudes. Okay. Questions, concerns, Cash?
Does amplitude affect the wavelength and frequency, or is that just its own?
It's its own variant.
Okay.
And it becomes better. So did you guys do sine, cosine, tangent?
I have in the past, but
Okay, so you're going to get a little bit of sprinkling of that here as well too, because you're working with oscillating functions, and so that's going to
Okay.
play a part. And then sine, cosine, all that is, they're just oscillating functions. So we will be touching on that just a little bit, okay? And then in that situation, that also has to do with your amplitude. So if we were trying to graph this function, right? Amplitude, you'll have an equation, and then you'll have like sine or cosine depending on what your amplitude and your oscillating function looks like. Okay. Clear, clear, clear. Okay, so let's talk about the electromagnetic spectrum. A spectrum is just basically a light spectrum, like a range, of different things. So visible light is only a portion of the electromagnetic spectrum. We also have UV light, we have X-rays, we have gamma, and so they're all part of the electromagnetic spectrum as a whole. So visible light is only just a tiny fraction of it. And I'm just going to show you that, okay? So here, cosmic rays, which are gamma rays. Your PET scan, gamma rays. Your X-ray, right? UV, so UV here, infrared, okay? So like you guys have gone to the dentist and they cured your, like I've recently have a shitload of cavities. Never had cavities when I was a kid. I'm getting them all as an adult. Yes, I get that from my mom. She's the exact same way. No cavities as a kid, but as an adult, they all come in. And so they basically cure anytime that you get your teeth filled. They use a curing agent to sit there and make it hard. And so they basically use UV light to sit there and do that curing. The remote control, infrared, night vision, infrared, radar, right? So that's representing your microwaves. Our wireless networks, microwaves, microwave oven, microwaves, right? Our cell phones, tons of microwaves going in our head. The ultrasound, right? So then we're getting into radio and broadcasting waves. So those are just sound waves. AM radio, FM radio, sound waves. Okay, so all of those are electromagnetic energy. They're electromagnetic waves. Okay, so if you take a look at this, this gives you a beautiful image. So the frequency here is greater. The wavelength is smaller. So as we go from gamma rays to radio waves, right, our wavelength gets bigger, but our frequency gets smaller. Okay. So now, in theory, under ideal circumstances, the speed of light is going to be the same for both circumstances, right? In all the cases. Now, here's the other thing is that as the frequency gets bigger, the energy also increases. So there has to be a relationship between frequency and energy, okay? And so we're going to be talking about that, okay? So let me get through this. Okay, so let's start off simple first. So a sodium street lamp gives off a yellow light that has a wavelength of 589 nanometers. So 1 nanometer is equal to 1 times 10 to the minus 9 meters. What is the frequency of light? So here we're going to basically be using the speed of light equation because we're talking about light. Makes sense. So C equals lambda nu. So we want to calculate the frequency. So we're going to solve the equation for nu. So what are we going to do next? What are our knowns?
RC.
Okay. Okay. And we know that C is equal to what?
The speed of light.
Okay. I'm going to be lazy. And round 3.00 times 10 to the 8th meters per second. And what else do we know?
Take
Wavelength.
that divided by the wavelength,
Okay. And the wavelength is what?
589 nanometers.
Okay. So since these are in meters, we could either convert these to nanometers, or we can change our nanometers into meters. We want to make sure that our units are consistent. So how can I change nanometers into meters?
Mm,
1 nanometer is equal to,
oh, we can multiply 589 by 1 times 10 to the negative 9.
okay? So we can use this as a conversion factor, right? So if we use our equation here, right? So we have nu, we start plugging everything in. So we get 3.00 meters per second over 500 nanometers. Oops. So if we have 1 nanometer is equal to 1 times 10 to the 9th meters, or 10 to the minus 9th meters. So the nanometers are going to cancel out, meters are going to cancel out, and then we're left with just hertz. Okay, so if I remember correctly, we'll have 1.09 times 10 to the 14th. I have to move my hertz here. Give me a second. Okay. Piece of cake? Oops.
Yep.
Only thing I forgot to put times 10 to the 8th here. Slacking, man. First day of class. There you go. Okay. Questions, concerns, Cash? Okay, good. Okay, so these are basically cell towers and radio towers. And so these guys are basically used to transmit that electromagnetic energy or that electromagnetic radiation. So that's how we get our signal and stuff like that. How many of you guys live near a cell tower or you do?
Yeah, I can see one from my house.
So, you know, there's been this debate, and there's a lot of people that have been studying the effects of cell tower on development, child development, stuff like that. And then also in terms of how it affects adult and causing Alzheimer's and things like that. And so there's a whole group of people that strongly believe that these electromagnetic waves do have an effect on our development and how we respond and some of the disease that happens later on during life. But it's been kind of spotty. So it's sort of interesting to sit there and see, you know, as science improves and how we continue to use our cell phones. Now, how many of you guys are constantly on your cell phone? Have it next to your head or in your pocket next to your reproductive organs? Anyone? Or am I the only culprit that does that?
I always set my phone away from where I sleep because of that.
Yeah, that's good. Yeah, you know, and it's going to be interesting because, you know, like when I started, you know, there wasn't cell phones. This is bad. I'll date myself here. There weren't cell phones initially. We had little beepers, right? And those were also electromagnetic, but the level of electromagnetic waves that were emitted from there were much smaller than what they are today in our current cell phones. And so it's going to be interesting to see the effects of that over time and how much that causes mutations within the cell, because all of these guys are kind of playing a part on each other. Because remember, it's a wave particle duality, right? So they're also going to be affecting your cells in your body, which are consistent of matter, you know, so they're affecting those electrons that are being there as well. And we're going to be talking more and more about that. And then also how it pertains to the environment and also how it pertains to you, okay? I think I am going to stop here. I think this is a good stopping point, even though there's 165 or sorry, 156 slides. The rest of the stuff will come pretty fast. But I want to stop here since this is our first day of class. I don't want to overwhelm you, but it's good to see familiar faces. Hopefully you guys enjoyed the lecture, and then I'll see you guys on Wednesday. Oh, there's no lab today as well. Okay.
Dr. Henry, are we going to have to sign up for the tutoring again like we have last time?
Yes, you're going to have to sign up for NC 100. Thank you for asking me. You are going to, let me stop this. You're going to have to sign up for NC 100. And so all you guys sign up for NC 100. And then there's also going to be extra credit points if you attend at least 3 tutoring sessions. So if I have proof of you attending at least 3 tutoring sessions, you'll get some extra credit points added onto your test score.
3 tutoring sessions per week?
No, it doesn't have to be per week. I just wanted to get you guys, because I think tutoring is kind of like a drug. Once you get started, you get that first little hit, you're like, okay, I'm good. Okay, you get that second hit, oh yeah, I'm really good. You get that third hit, oh, I'm hooked. You know.
So 3 times in the semester?
Yeah, 3 times in the semester. I just wanted to get you guys accustomed to going, you know, and I think 3 times, if you go 3 times, it's good. But if you're going 3 times a week, that's even better, you know. Okay. Then I'll see you guys on Wednesday morning. You guys have a good morning.